right, Unit 6, Lesson 7, Beyond 2 pi. So 10.1 all the way around. Here's a unit circle with a point A marked at 1, 0. For each angle of rotation listed here, mark the new location of A on the circle. And so we're going to call that by a different letter. Be prepared to explain your answer. Okay, so the first one is B, which is pi over 3. And so that would be right about here, because this is pi over 4, and this is pi over 2. This is 3 pi over 4, and this is pi, and this is 5 pi over 4, and 3 pi over 2, same thing as 6 pi over 4, and then 7 pi over 4, because those are all 45-degree angles. And so in radians, they're pi over 4s. So pi over 3 would be a little bit bigger because 1/3 is bigger than 1/4. And hopefully we remember from before that pi over 12 is 15 degrees. So every 15 degrees is a pi over 12. So 30 degrees would be 2 pi over 12, which is the same thing as pi over 6. And so then pi over 3 is the same thing as 4 pi over 12. So that would be 4 times 15, which is 60 degrees. All right, so let's take a look at C. C is 4 pi over 3. Well, we had 1 pi over 3 here, and then we would have 2 pi over 3 goes to about there. This would be 2 pi over 3. And then 3 pi over 3. So then 4 pi over 3 would land right about there. So 4 pi over 3 would be about there, and that was C. Number 3 is D, 7 pi over 4, which we already labeled. We already said that one because we went through and labeled all of our pi over 4s. So 4 is E, 5 pi over 2. Okay, so here's how we're going to find that one. So 5 pi over 2. So if we go here, that's 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. So 5 pi over 2 is the same as pi over 2. So that one is your E. And then 6 pi over 2, you're just going to go one more pi over 2 counterclockwise, and so that would be F. So F is the same thing as pi. That's also the same thing as 3 pi, right? Which is the same value as pi. All right, let's take a look at 10.2, going around and around and around. The center of a windmill is at 0, 0, well, is 0, 0, and it has 5 blades, each 1 meter in length. At point P, a point P is at the end of the blade that is pointed directly to the right of the center. So, okay, so we have a windmill, and it's going to look something like this. Pretend those are blades, right? And each of those is 5, no, there's 5 blades. Each of those is 1 meter. So each of these is 1 meter. And a point P is at the end of the blade that is pointing directly to the right of center. So I probably should have drawn this slightly differently. Let me fix that. So directly to the right of center. So there's the first one. That's one, that's one, that's one, and that's one. Okay. And so again, this is 1 meter, and point P is right there, directly to the right. So here are the graphs showing the horizontal and vertical distances of point P relative to the center of the windmill as the blades rotate counterclockwise. So the blades are rotating that direction, and point P shows the graphs of the horizontal and vertical distances, those sine and cosine, or cosine and sine, because cosine is horizontal and sine is vertical. All right, so how many full rotations are shown by the graphs? So if we look, we're starting here, and when we come back up to that point, that's 1 full rotation, and then we have this, that is 1 full rotation, and then this one does not come all the way back up, so that is not one full rotation. We can also see here is one full rotation, comes back to the starting point. Here is another full rotation, and then this one is just a half a rotation. So full rotations, there would be 2.5 full rotations. And we can see that because each graph makes 2 complete cycles. Two complete cycles and 1/2 cycle. All right, what do the values of the graphs at 0 equals 3 pi mean in this context? So where are those values? 3 pi, so here and here, right? And so the point P has rotated how many times? 1.5. So P has rotated 1.5 times, right? Because you have the whole blue highlighted cycle, and then it goes to half of the orange highlighted cycle. And the point P, so if it's gone 1.5 times around, if it started at the point 1, 0, and it went all the way around and then halfway, it would be at -1, 0. So is at -1, 0. List some different angles of rotation that bring P to the highest point in its circle of rotation. So thinking about the highest point, and so the highest point would be up here in the rotation, and so that would be at pi over 2, right? Because that's at the top of the graph. And then if it were to come back around, I'm going to get rid of some of these drawings. All right, so pi over 2 is the height, right? And so if we come all the way around, we're going to add 2 pi to that. So pi over 2 plus 2 pi gives us 5 pi over 2. And so you'll notice that every time we go around the full circle, we're adding 2 pi. So we have pi over 2 plus 4 pi, because that's 2 pi plus 2 pi. And so that is going to be 9 pi over 2, right? And so we could actually write this as pi over 2 plus 2 pi n, where n is an even number, right? And that would represent all of the different angles that have that same amount of rotation. All right, and then number 4, how many angles show point P at a height of 0.7 meters? And so when we look at this, you might see that it's at different places depending on whether you're looking at the horizontal, the sine graph or the cosine graph. And so if we draw a horizontal line, we're talking about a height of 0.7. So that's like right about, oh, that's really thick. That's right about here. And so you see 1, 2, 3, 4, 5 for cosine. But then if you look at sine, you're going to see 1, 2, 3, 4, 5, 6. So it depends on which one you are looking at. But for the sine, so for cosine, we had, I don't want to put equals because it doesn't equal. We had 5 of them, but at sine, because we only went to 5 pi, there were 6. And so again, you can show your reasoning by drawing that horizontal line to see where the intersection points are. If you are asked to explain or show, then you need to do that in that problem. So you can look and see where the horizontal line y equals 0.71 intersects y equals sine of theta or y equals cosine of theta, depending on which one you're talking about there. All right, let's take a look at 10.3, back to where we started. The point P on the unit circle has coordinates 1, 0. For each angle of rotation, state the number of rotations defined by the angle, and then identify the coordinates of P after the given rotation. So one of the things I'm going to do here is I'm going to bring up, because this is going to make it easier for those coordinates, I'm going to bring up our unit circle. All right. And I'm going to make that a little bit smaller. Yeah, we can still see that. Okay, so the first one is done for us. We have 3 pi over 2, and you can see 3 pi over 2 is pi over 2, pi, 3 pi over 2. So it would be right here, and we can see on our unit circle right there that it is 3/4 of a rotation. The x coordinate, the horizontal coordinate, is 0, and the vertical coordinate is -1. All right, so now we're looking at 25 pi over 12. Well, remember that 2 pi is 1 full rotation. And this is the same thing as 2 pi plus 1/12 pi, right? And so that is about 1 1/24 rotation, because if we divide that by 2, because 2 pi is our full rotation. So if we do 25 pi, oops, I forgot my 5 pi over 12 divided by 2 pi, because that's how many are in a full rotation, that's the same thing as saying 25 pi times 1 over 2 pi, right? And so your pi's cancel out, and that's 25 over 24, which is 1 1/24. So that is the number of rotations. You can just divide whatever your angle measure is by 2 pi to get the number of rotations, because you're dividing by 1 full rotation. All right, I am going to get rid of that just because it's messes up some of the other stuff. So then if we look on there, 25 pi over 12, that's a little harder to see. It's not actually on the unit circle because we don't have pi over 12, because it's the same thing as pi over 12. But what we can do is we could use our calculator. And so let me actually just bring up the calculator. And so let's clear all that. And so we are doing the horizontal, so that's cosine. And again, we need to be in radians here. So we're in radians, cosine of 25 pi divided by 12. And that is about 0.97, 0.97. And then we can go over here and change that to sine, which is the vertical, and that gives us about 0.26. All right. Okay. Now we're gonna bring back that. There's probably a better way to do this. I should figure it out. Bring back our unit circle. And we're looking at 5 pi over 2. So we're going, so this is pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. So 5 pi over 2 is the same thing as pi over 2. It doesn't equal, but it's the same as pi over 2. And so that is 1 1/4 rotations. And we can see that our x value is 0 and our y value is +1. All right, then we're doing 7 pi over 3. So here we go up to 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, and you can see that right here. 5 pi over 3, 2 pi is the same thing as 6 pi over 3, so then 7 pi over 3 is the same thing as pi over 3. So that is the same as pi over 3. And so that was, remember, we went around the circle and then up a little. So it was, there are 6 pi over 3s in a full circle, so that's 1/6. So it was 1 and 1/6. And our x value is 1/2. And our y value is the square root of 3 over 2. You can change that to a decimal if you want to. You can plug that into the calculator like we just did for the 25 pi over 12. That's fine. But you will often see it written as this fraction with an irrational numerator, at least for the sign. All right, so 49 pi over 12. So this is one that I am going to divide by 2 pi. So I'm going to multiply by 1 over 2 pi. And so I end up with 49 24ths. And 49 24ths is the same thing as 2 and 1 24th. Because 49 divided by 24 is 2, because 24 times 2 is 48. And then I have 1 left over. So I'm going 2 full rotations around and then landing at 1 24th. Now, keep in mind that these two are landing at the same place because they both made full rotations and then ended at that 1 24th. So those horizontal coordinates are going to be the same. And so are the vertical coordinates. So after you make those full rotations, if your fraction, your amount of rotation that's left over is the same, then you have what's called the same reference angle. And so your x and y coordinates are going to be the same. All right, and then 5 pi, we're going around. There's 1 pi, 2 pi, because remember every pi is a half circle, 3 pi, 4 pi, 5 pi. So that's going to be the same thing as pi. Right, and so we went around 1, that was 2 pi, 4 pi, so 2.5 times. And then so we know our horizontal coordinate is -1 and our vertical is 0 because we can see that over here on our unit circle. All right, in general, if theta, that's your angle measure, is greater than 2 pi radians, explain how you can use the unit circle to make sense of cosine and sine. So again, we're looking at the reference angles. What angle is the same on that unit circle after you take away those full rotations? So you look at the amount of rotation left after the full rotations and use the corresponding angle on the unit circle. Okay. And then you have, we're not going to do the are you ready for more, but there's your lesson summary if you want to take a look at that.